I'm back with number 5 on page 69. I started this on the last video and I got it in such a mess that I thought I better just stop, cut it out, and do it again. So here I am. In my tenure as an adult ed teacher, this is one of the hardest problems to explain that I've ever come across. And I think it's just me. It's not the problem as much as I just am having trouble getting an explanation out. So let me try here. It says there is another formula for combinations. Explain how it is like the formula in the lesson. Well, first of all, I would not worry about this problem terribly. Don't lose sleep over it. It's a theory question, and those are always kind of difficult. The combinations formula that you and I have been using is this one. The combination of NK is the permutation of NK over K factorial. And I forget to make that funky K. When I was in college, I had to learn to do that. That's how you teach little kids, I think, to make Ks. And I still can't get the hang of that. But anyway, this is the formula that you and I have been looking at. And then this is the formula that's given to us in the textbook. We still have combination of NK. That's nothing different. But this one has N factorial over K factorial, N minus K factorial. So just when we got used to this one, they threw in this one. And they're telling us that they are the same thing, and they're asking us to explain how that can be. That's the gist of this problem. So I'm going to start with the formula that we're used to. It's bad enough. And I'm really going to just zoom in on this part of the formula. And I'm going to zoom in even more, if I can, on just this part of the formula. So I want us to focus right here for just a minute. In this lesson, when we've had to find permutations, we've used a formula, right? We said the permutation of NK is N factorial over N minus K factorial. We've been using that formula all along in this lesson. So watch what I'm going to do here. I'm going to take this out, and I'm going to take it out up here as well, because this is the same thing that I just erased. Let's get rid of that. And since it equals this mess over here, I'm going to bring this mess right down here. Am I allowed to do that in math? Yes. As long as things are equal. Let me walk you through it again, what I just did. This is what we started with. So I erased that, and I said that's the same thing. And then I brought this down here because it's the same thing. Everything was equal. And then I made it a little bigger. Okay, so all I've done is substitute that part of that formula back in here for permutation. And you're thinking, well, you just made it worse, because now it really looks scary. And it does. I will agree with you that it does. But what I want to show you here is something that is really an algebra concept. And for those of you who have had algebra, this should make sense. If you haven't had algebra, it's going to be hard to follow. So just hang in there with me. Remember, we're not losing sleep about this problem. You can split. Let me not do it that way. Let's split. Let me think before I create more chaos here. Let me do it this way. I'm going to rewrite this thing as, and let's eliminate what we can here. So I'm going to rewrite this thing as n factorial over n minus k factorial times, because this k factorial's on the bottom there, I'm going to keep it on the bottom, but I'm going to put a ghost 1 up here to hold the top. That means the same thing. The top that's red and black means exactly the same thing as the purple. We're taking this big old ugly fraction and we're bringing it down here. And then we're multiplying it by this fraction bottom. And I'm putting a 1 there to hold the place. So those mean the same thing. This value and this value are exactly the same thing mathematically. You could write it either way. Now, look at this. Okay. I'm going to put this, I'm going to make a copy of it and bring it over here. So we're left with n factorial times 1. That's n factorial. And then on the bottom, we're left with k factorial times n minus k factorial. And that's the term that we have right here. So these two equations are in fact equal. You can use either form of the equation. I'm going to tell you to stick with the equation we've been using. I'm going to tell you to forget all of that and use this formula for combinations. If I had written this textbook, I would not have put this in there. To me, this is just unnecessary confusion. If you have an extremely strong algebra skill set, you can do this. But you don't need to worry about this. Just don't even worry about it. Keep the formula that you know how to use. And just forget that we ever read this problem. I don't like just not doing problems, but in this case, I should have just left it. I should have just said, nope, we're not going to touch that one. We're going to use the formula that we already know. Or better yet, use the calculator. I was going to try to put those steps in there. All you need to know if you're taking the HiSET test and you're using the Casio is this. I should have just left this problem. I'm tempted to not even upload this video, but as sure as I don't, someone's going to ask for it. So I think I'm going to go ahead and upload it. I probably will put a caveat that if you're even the least bit confused, skip this problem. Okay, so we're going to put in the n value, shift to the k value, and equals. That's all you need to remember, and this will work. Thank goodness we're to the end of this lesson. I am going to check these problems because I have not done that. So let me go back and go to page 68 in the answer key. And here we go. Did I do the vocabulary? Let me just go back and do it all to be sure that I have it 68 is factorial, experiment, outcome, combination, tree diagram, permutation. Number 1 at the bottom is B as in boy. 2 is C as in cat. 3 is D as in dog. 4 is A as in apple. 5 is D as in dog. 6 is C as in cat. Number 1 at the bottom is 8 choices. They say 8 options, but it's the same meaning. Number 2, no, he was not correct. Order does not matter, so you should find the combination. Andrew found permutation. The correct answer is 220, so we got that one right. Number 3, there are 24 combinations, and they said to use the counting principle, so I didn't need to draw the tree after all. Number 4, possible answers include the 14 factorial and the standard notation. That's interesting. So they used this one and this one as their choices, but it says possible answers, so they would accept that one, this one, and this one. Any of those would be appropriate. And then number 5, I don't even want to look at it. Let me see. Yes, they did it the same way we did, except theirs is written in more narrative form. But again, don't sweat number 5. All right, in the next video, we will be looking at the exercise set for this lesson. So if you want to try that on your own before you watch the video, you will need to go to the exercise book and do pages 31 through 36. Oh my goodness, there are 35 problems there. So if you want to use that as a practice test, try that, and then you can watch the videos with me to see the explanations. So I will see you soon. Bye-bye.